So section 7.5, we're graphing square root and cube root functions. The essential question, how can we quickly graph square root and cube root functions? We've got this. So first off, these are transformations of any graph of any function. Whether I'm talking logarithms, cubed roots, sines, cosines. This is also formal notation. Formal notation. F of x. Anytime I read f of x, I'm going to put this off to the side. Anytime I read f of x, I'm going to look at that as outputs. This is, by the way, in your textbook. This table. Anytime I see f of x, I'm going to think outputs. Anytime I see x just by itself, I'm going to try to interpret it as inputs. So, to make this stand out, I'm going to use color now. When I see f of x plus c, wait, f of x, there's no interruption there. F of x, I'm going to read it as outputs. I'm going to take all the outputs plus a number. So if I have a table, I'm going to take all the outputs, meaning the output column, that's the y column, I'm going to take all the outputs and add a number. So this whole thing saying shift f of x up c units, that means we're going to take the outputs, add 3. Or my bad, not 3. Add a number. I don't know if it's 3. I was going to say c and then my head had a hiccup. F of x minus c. That means, wait a second, again, you're looking at f of x, no interruption, so that's also standing for the outputs. If you see f of x minus c, that means the outputs subtract a number. F of x plus c. Now wait a second. That does not say f parentheses x parentheses. Or I shouldn't say. It doesn't have those symbols right by each other. So this is not a straight output. That means I'm affecting the inputs. So if you see the inputs adding a number, it means so first off, the inputs are being affected. Inputs subtract a number. Inputs are affected inversely. In a similar manner, the next one, because it doesn't say f parentheses x parentheses, it says x minus c in parentheses. That means the inputs are being affected, and inputs are affected inversely. So inputs in this one will add a number on its side of the table. So here we go on the last four. The last four I'm not really going to talk about. That's more for trig pre-calc. That's more advanced. So we're going to concentrate on the top four. Are we adding, subtracting? Is it affecting the inputs or the outputs? Now, those of you who just want to talk about it, notice where the negative's at. So, if the negative's on the inside of parentheses, negatives on the inside, it's affecting the inputs. Negatives on the outside, it's affecting the outputs. So all the outputs would be multiplied by a negative. Notice if it's multiplied by a number, the function is, or the outputs are multiplied by a number. If the inputs are being multiplied by a number, think about this. Inputs are affected inversely. So if you're multiplied by a number, technically it affects the table inversely. You would be dividing by that number on the input side. All right, so we're going to look at tables. Again, we're going to go through this looking at tables, and then we're going to get so good at it that eventually we'll do this in our head. All right, let's talk about tables. You already have this on your guided notes. What we're about to do is figure out how G looks, or it says describe how to obtain the graph of G from the graph of F. we're going to figure out how G will look in comparison to F. Well, first you got to figure out, wait, F's shape. So here's F's function, and this is what G's doing. So this is how we interpret, okay, you don't know exactly how to go about this. Notice how f of x equals the square root of x. Notice how you see that in G's function. Here's what I'm getting at. I could rewrite g of x to be, instead of square root of x, I could say f of x, since f of x equals square root of x. And then go back to plus 3. So that way we can somewhat go back to that table on the previous page of your notes and figure out, well, how would this change the graph? Or how would this change the table? Let's describe what happens in the table. So you've got to figure out, are we affecting the input side or the output side? So, because the number's outside of f of x, we're going to say that the outputs add 3. What this means is, in terms of the graph, since we have to describe it, this means all of the original points move up 3. Since the outputs are the y column, so outputs are the y column, and the y-axis is up and down. If you add 3, that means you're shifting up 3. This is how we would describe it. All points move up 3. Here we go. So now we've got a function. Our g of x is equal to cubed root of x plus 5, and then f's function is the cubed root of x. So we've got to figure out, wait a second, do we have this exactly in our previous function? And it looks like, well, wait a second, yeah, it's right there. The bad thing is, whoa, x plus 5 is the entire radicand, not just a plain old x. So I cannot just say that this is f of x. X plus 5 is inside the function. So what I got to do is, this is technically f of x plus 5. X plus 5 is being added first, and then it's taking the cubed root. This is how that would be written. So all the inputs are affected inversely. So instead of adding 5, inputs subtract 5. Then we've got to realize, okay, if the inputs subtract 5, I've got two options. Either look back at the table on your previous page in your notes, or, okay, inputs is your x column, and your x column is your x-axis. That means you're moving either left or right. If I'm subtracting 5, that means I'm moving left. So all points move left 5. I'm not going to test you over whether or not you know how to rewrite this using function notation. But you do have to figure out, well, what's affecting the inside, what's affecting the outside, what's affecting the inputs, what's affecting the outputs. And inputs are affected inversely. So, I notice the -1 is on the inside. So inputs are affected inversely, so inputs will add 1. And that means that, well, wait a second. I'll get there because apparently I've got a -4 outside. So now outputs subtract 4. So all points move up 1, left, no. Inputs move left to right. So this moves right 1, down 4. So whatever the original points are, I'm going to shift them right 1, down 4. All right, so here we go. Inside is affected inversely. Outputs add 6.